know about, and we can talk about it because they're actually going to be inverses of each other, in which we know what inverses are. So what happens to all of the x and y values when we have inverses? They flip. So here is my exponential function. So all of these values are just going to flip. So I'm going to have 1/8 here, and then a -3. I'm just going to go in order. It makes it a little bit easier for me. Follow these, switch. 1/4, 1/2, 1, 2, 4, 8. And go ahead and take a minute and plot now your new function, which is a logarithmic function. Okay. The way you would say this is log base 2 in this situation of y equals x. So go ahead and plot those the best that you can. Oop. Okay, it should look something like this. It does not have to be perfect. Okay. And again, we should know that, again, because they're inverses of each other, we have this line y equals x, which it's symmetric about, which is true in this case based off our visual here. Okay, so now again, recall that the domain and the range of inverse function also interchange. So what's nice about inverses, if we know the domain and range of one of them, then everything just switches for that inverse function that we're talking about to relate to. So what is the domain of our exponential function? What are the x values for our domain of the very first one? Yeah, -infinity to positive infinity. Okay, that was this guy here in green. That guy in green goes forever left and forever right. What about the range? Bottom to top. A lot of people struggle with the range on the quiz. Bottom to top. Yeah, 0 to infinity. Do I include 0? No. Now, this is where things get a little bit tricky because we learned about horizontal asymptotes, which in this situation we do have one, but we're talking about the inverse. We're going to have something that's opposite. For this function, we have a horizontal asymptote. Horizontal. And where is it at? What is the, yeah, y equals 0. So this piece right here in red is that horizontal asymptote. Okay, make sure you're putting the correct notation on the quiz. What we noticed too is that you put just 0. 0 tells me absolutely nothing about a graph. Okay, so make sure that that notation is proper when you're talking about math here. Okay, so now we have, do we have any intercepts in this first situation in green? Yeah, is it an x or a y? A y-intercept. And where is it at? 0, 1. Thank you. Again, because, stressing the notation, because on the quiz, some people just put 1. Or they put y equals 1. That's a line. Y equals 1 is a line. Whereas 0, 1 is a point on the graph. So make sure that you're understanding the notation. Okay, I wrote these end behavior statements out, so take like 30 seconds and just prep your work. Because I like to just prep my limit statements. On the quiz, we gave them to you, so that was nice. But it's nice that you would be able to write them out as well. So the way that you say this, as you're writing, the limit as x approaches -infinity, basu. As x approaches -infinity, which really just means as you're looking at the left side of the graph. Where does the function, or those arrows that end behavior, where does the end of the graph go to? Okay, so for this very first situation, when I zoom in here, okay, I'm x, and I'm going towards -infinity. I'm looking at the left side of the graph, and I think before when we taught you last semester, we kind of just like covered up this side. Where is the function approaching? 0. Okay, we're approaching the y value of 0. That's kind of what we're looking at, the y value, not the x value in the situation. Now, on the opposite side, where is it approaching? Infinity. So if you follow the graph towards the right side, follow it towards the right side, it's going up, and it's going up to positive infinity. Okay? Oop. Questions on that part? That's all kind of information you should have known for that quiz. Okay, so if you want to think of it as the negative side to the left side, you can follow the graph to the left side. And then on the right side, you can follow it to the right. Okay, it kind of helps you when you're mapping that out. Now, when we're talking about inverse functions, what's really, really nice is that basically everything just switches. They interchange. The x and the y interchange with each other. So the domain and range are going to switch. So what's nice is that now our domain becomes our range, and our range becomes our domain. And when you look at the graph, it's valid. I mean, the one that you drew in, it validates that. Okay, the range goes forever down and slowly forever up. But the domain now starts here, if you notice. Starts at 0, and it goes on forever to the right side to infinity. Okay, questions on that part? Now, instead of a horizontal asymptote, what kind of asymptote am I going to have now? A vertical. So again, everything basically just switches. And where is the vertical asymptote at? Yeah, very nice. So some people were like, oh, y equals 0. But in this situation, again, the x and the y values interchange. And that's why it's now x. And it makes sense. Look, it doesn't look like my graph is going past the 0 mark. And that's true. Okay. Your asymptote, which a lot of people did not make this correlation on the quiz, just kind of like, I mean, a lot of you did really well. So I'm not saying that you guys did bad. But little mistakes that we're seeing is that they're not making the correlation between the asymptote and the end behavior. If you notice, they're the same. And the range. Okay, so that 0 was used on all 3 of these for a reason, because the range is restricted for this first one. The asymptote, because of the asymptote, your range is restricted, which then means your end behavior is going to be restricted. Okay, so that's kind of a good correlation to have. Some people had like 1 in the asymptote, and they had 0 in the range, and then they had like 5 in the end behavior. I'm like, ooh, okay, that just makes me really makes me know that you guys weren't understanding that they all correlate with each other. Okay, just some of you, not all of you. Okay, so then we now have a what intercept? X, and where is it at? 1, 0. So you can see kind of how it flip-flopped. Now, this one is a little different. Okay, this is like the only situation that won't flip-flop, because whenever you have a range that's all real numbers, you're going to have your end behaviors also involving those infinity signs. Okay, so if you notice here, this 0 was affected because of the range was 0. But we don't have a range that's restricted. So now let's take a look. As my function starts going to the left side of the graph, where's the y value starting to go? Negative infinity. Let me get down here so you can see. And then what about the right side? Yeah, to positive. Okay, I know it looks like it's going right, but it's actually slowly going up too. So make sure that you understand that. Do you have questions on that part? Okay, so for both exponential and log functions, your base value has to be greater than 0. Same thing as what we did last week and the week before for exponential functions. And remember that b cannot be 1. That base cannot be 1, because then you're really not exponentially growing. Because 1 to any power in the world is going to be that number, because it's just 1. Okay, flip when you're ready to go. Okay, here we get to the real math of logs, and I think logs are fun, but that's just me. So that b is still going to be your base when we talk about logs. The y is what we call an argument, and the x is what we call the exponent in this situation. So again, how you say that, it's log base b. So if it was a 2, you'd say log base 2 of y equals x. Okay? All right, so let's do some examples here. Example. Kind of give you like a little bit of a tip here. Whenever you have a log, this base, you basically are saying, you want to think to yourself, 10 to what power gets me 100? Okay, so just like in your head, you can ask yourself, 10 to what power gets me 100? 2, and that's your answer. Okay, so you can do these pretty quick. 7 to what power gets me 49? 2. So you're kind of asking yourself, 7 to question mark gets me 49? Maybe that kind of helps you with that. 7 to what gives me 49? So then here, 3 to what gives me 81?
4.
Is it 4?
Yeah.
4, okay. There we go. And then here, do this one on your own for a second. This is something that we would hope that you'd be able to do without a calculator. We will obviously would not give you like really difficult ones for the non-calculator portion, but 5 to what power gives me 125? What'd you say? 3, good. So pretty straightforward. And now that you kind of know what a log is, or the notation of it at least, you might be able to apply that now to your SAT. Okay, so when we're going back and forth between a log and an exponential equation, this is how you do it. And I'm going to show you kind of a little trick, and if you're a girl, or maybe you like hearts, even if you're not a girl, I do like the heart method. 2 raises the 8 up to the power. Sorry, I'm going the opposite direction. Log base 2 of 8 is equal to 3. It's kind of like a little heart, a little trick. Or if you're like, hey, I hate hearts, I don't want to write out hearts, or some of you might even be able to do it without even writing anything down. You can do it this way. 2 raises the 3 up and brings the 8 to the other side. Okay, it's kind of like a little trick to help you get it in the right notation. So let's actually practice it. So when you're going from exponential to log, I'm going to write my log out first. You always start from left to right like you read. So log base what? Oops. Log base what? 4 of 16 is equal to, see how the heart kind of like hits it? 2. And that's how you would just rewrite it going back and forth. Try the next one. See if you can just use that guide to help you with your notation. Oh, if you're going for exponential to log, you better have a log in there. Some people will just write like 4/16 equals 2. Oh, that's not true. Okay, so make sure that log is in there. And this is very beneficial when you're given something and you can now do it mathematically. Okay, so you now can look at this and say, oh, I know how to do this. I can raise that 3 up to the power to give me 8. What did you guys get here? Very good. Okay, so I'll do it the other way. So you always start left to right. Log base 2 of this number is equal to -5. Okay, if that helps you, like that little trick to get you a little swoop here. Okay, now let's go reverse. This one I think is a little bit easier because again, you're reading left to right. Always start left to right like we read. So we start with the 9. So the 9 is raised to the 3 exponent here. So 9 cubed is equal to 729. Questions? All right, do the next one. See if you got the same thing as me. Not too difficult, right? Just going back and forth.
Do you always put the fraction in brackets?
You don't have to, but I do. Because your calculator sometimes is tricky if you don't. You do not have to put it in there, though. Okay? All right, now let's move down to the bottom here. 2 frequent logarithms that we use is a base 10 and a base e, which we talked about what e meant. It was like 2.72 something when we did exponential population growth last time. So if you look on your calculator right now, I kind of told you guys in the past that the inverses are always by each other on the calculator, which is super cool. So if you go find your ln button or the log button, the ln and the log button, okay, those are going to be your best friends for the next couple weeks, even next chapter as well. Okay, the log button will automatically have a base of 10. So it's kind of like how the square root, that imaginary 2 is there. It's the same thing. The log has a base of 10. Okay, but now we have something called a natural log. And what it means to be a natural log is that it has a base of e, that constant e. Okay, and that's what that ln button right underneath, I'm going to steal Katie's here. There's a log button, and then there's an ln button. Those are now your best friends for the next couple of weeks. The ln is the natural log, think n and l, natural log, and then the log is your base of 10. It's really cool. If you look right above it, look, ln has e to the x power. Hint, 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 that's the inverse. Same thing here. Log has a base of 10, where on the top of it says 10 to the x power. They do that for a reason because they are inverses of each other. It's really cool how they set up the calculator. So now let's go back and forth between these. If I don't give you a base here, what is it? 10. Very good. Okay, so if I don't give you a base, you can even write it in if you really want to. You don't have to. And then you have 10 squared is equal to 100. Cool? Now let's reverse it. I have log base e, I'm just going to write this out for the first time, of 7.39 is equal to 2. Now, mathematically that's right, but we like to make it in proper notation. How do we represent log base e? There's a way to now write that out without being, ln. It's called the natural log, or ln of 7.39 is equal to 2. Questions on that part? Do the next one. Be careful. Sometimes it might be beneficial for you to rewrite what ln really represents. The natural log really represents something. Kind of did it up here. And when you're done and done only, you can start looking up. So I'm just going to rewrite it first for you to see what it looks like. Check your answer when you're done and flip. And so just practicing here what... Oh, this is day 9. Oh, we're done. I thought we weren't done. I was ready to go more into depth about it. I was super excited. Okay, I really like logs. I think logs are really fun to work with. I think it's cool how you can interpret logs. And we'll talk more about what logs really do in everyday life tomorrow, okay? All right.